Good morning, good evening, good afternoon, depending on where you are. Today is September 19th, and this is another of our bi-weekly SIG Apps call. My name is Maciej, and I'll be your host today. Before we jump into 126 items that we're going to cover, a quick reminder, the enhancement freeze for 126 is roughly 2 weeks away. It's on October 6th. I didn't even properly calculate it, but I think that's about 2 weeks, 2.5 weeks. It's Thursday. From this Thursday in 2 weeks, it is when there will be the freeze date. I linked their 126 schedule. Actually, try to get your reviews for enhancements sooner than that because the production readiness, which is a required step for all the enhancements, the soft freeze for that one is actually a week before the actual cap freeze. Because from what I remember, there were only two persons assigned as PRR reviewers for this cycle. So try to get through most of the reviews sooner than later. With that, I think we can jump over to main topic, unless Ken wants to add something. Not sure if I missed anything with regards to announcements, Ken.
No, I think you covered it all.
Okay. So first one on the list is Michał, Aldo, and Abdullah. I see both Michał and Aldo. Take it away.
Okay, let me speak. Hope you can hear me, right?
Loud and clear.
Great. So what I would like to draw your attention to is the enhancement that we are currently working on beta, called retriable and not retriable pod failures for jobs. So what we are working on beta is to extend the feature with handling pod failures initiated by kubelet. So maybe a couple of words about this feature in general. So in this feature, we tackle the problem of handling pod failures a little bit more for jobs, like a little bit more flexibly than what the standard pod failure policy of backoff limit gives. So with backoff limits, you can just configure the limit of retries. However, in many scenarios, you can tell already if it's promising to retry or not promising to retry a certain pod based on exit codes it completed with or based on its end state. However, what we discovered in the experiments is that the pod end state is like pod can fail in many different ways, and it isn't like standardized that you can look at reason or status to tell why the pod failed or what was the kube component that initiated the failure. So a big part or a part of the feature, basically there are two parts of this feature. One is to introduce the pod failure policy based on the rules that allowed you to express like the policy based on the, as I said before, exit codes and pod conditions. And the second part is to standardize the pod end state in terms of these conditions. So whenever, in ideal world, whenever we kill a pod or pod is terminated, we add some pod condition that is then easy to be interpreted in terms of, do I want to retry it or not? So for alpha, what we did, we introduced a new pod condition type called disruption target. And we add this disruption target condition whenever the pod is failed due to disruption. So for example, we added when we evict a pod due to no execute taint or due to preemption or due to API eviction. So in all these cases, it's not like the pod is it's a fault of the pod, it's just a disruption, and that is the reason of the pod failure. So we don't really want even to count this failure against the backoff limit. So this is, yeah, this shows an example pod failure policy that uses the disruption target, but also what it's using here, you can see is resource limits exceeded. So this is already hinting to what we want to do in beta. So in alpha, we added disruption target, but we only annotated the failures that were initiated by the either scheduler or controller manager, but with beta we want to cover kubelet, and kubelet is responsible for initiating eviction in a couple of scenarios. And I think the most problematic, or at least the one that took us the most discussion time, is when it's evicted due to the limits exceeded for resource like memory or disk. So what you see here is the proposed name of the new condition, resource limit exceeded, that generalizes for exceeded memory or exceeded ephemeral storage. However, we intend, as a result of the discussion, to change this name, because how do we tell if the limits are exceeded or no? So in our from our investigation, when kubelet initiates eviction due to disk limit exceeded, then it's easy because it's kubelet that checks if the limit is exceeded in its code, and that evicts the pod if it's exceeded. And then we can just easily inject the adding of the new condition there. However, for exceeding memory, it's a little bit more difficult to interpret, because kubelet is not doing the check itself. So it's out of memory killer that evicts or kills the container, and then the runtime container runtime sets the reason out of memory kill, and this is what we observe in kubelet. And the issue is that in some situations, actually, the out of memory killer can kill a container even if it's not exceeded the limits. But it was close. Or the node itself was under pressure, and then the out of memory killer has some algorithm to determine which pod or which container or process to kill, and but it does not necessarily mean that the limits were exceeded. So that's why the name may not be accurate. And then, as a result of the discussion, I think the currently leading approach is to name it like resource exhausted or something like this. But in general, I would welcome some input on how to, and if it's either possible to determine if the limits are exceeded, or what we intend to do is best what we can have. There are also a couple of scenarios when kubelet initiates changes which we can interpret as just disruptions. So, for example, if there is node pressure, then but there is no indication that the limits were actually exceeded, then we just add the disruption target as in the other cases. So there is also admission errors. But I think those are easier in general. So I think that's will be for my brief introduction of the feature and what we want to do in beta. If you have some questions, I think I can then expand more. But in general, any input either now or at the CAP is welcome. So that's me.
Thank you. Does anyone have any questions? Can we help? Okay, hearing none, we can jump to the next topic. In that case, of course, everyone are more than welcome to have a look at the CAP, read carefully through it, and leave the comments or suggestions in the PRs. Next on the list is Philip. We're going to talk about consolidating workload controller statuses. Go ahead, Philip.
Yeah, so I would like to follow up on the discussion we had regarding the consolidating workload control status. We originally planned to introduce the available condition for other workloads, but we identified a couple of issues with the available condition since it is mainly tailored for the deployment use case, and it's hard to reuse or have a similar construct in other workloads. I posted a CAP which is introducing a new condition called operational, which is still up to the discussion, and it's mainly to start a discussion how this condition should work and how it should operate, so we could reuse it across all the workloads and have like well-behaved behavior for consumers to use. So please take a look if you want on this CAP, and yeah, thanks.
Okay, does anyone have any questions for Philip at this point in time? Okay, hearing none, let's jump over to the next on the list, Ravi. I see you have two of them, but I didn't see an issue linked to the first one. Do you have that link handy? I have the pod healthy policy open, but I don't have the other one that you started.
I did not create any issue, Machi, for that. I will open a one. So the goal here is to have a CAP by end of this release. It's not that this has to be merged within the next 15 days or 20 days time frame. So I will open an issue and an associated CAP. The main thing that I wanted to get some feedback on is this some problem that rest of the folks are facing too, especially in a multi-cluster world where we have workloads that are spanning across clusters. And since PDB is actually specific to a cluster, it is actually causing the problem where we wanted to count PDBs across clusters to ensure that the disruption is allowed or not. So we have a couple of ideas on how to implement it. Deep is also here from Apple, who works with me on those areas. But we are wondering if anyone else has similar issues and how they have dealt with.
So it depends on the workload and how you spread it across multiple clusters. Can you talk more about your specific use case where it's insufficient? Like, are you spreading the workload across multiple clusters, and because of the way you spread it, there's like one instance per cluster?
Yeah, there is more than, most likely more than one instance per cluster, but at a minimum level, we have one instance of the workload per cluster. And we want to ensure that while the disruption is happening, especially within a cluster, we can use PDBs to ensure that there are no disruptions. But if we want to extend those PDBs across multiple clusters, is there a way to do it?
I mean, the short answer is no right now, right? Like PDBs are really, like, when we designed them, they were meant for controlling disruptions for things like automated node repairs, right? Like, so you're upgrading all the nodes in your cluster and you want to find a way to go through and knock nodes over one by one, maybe move faster than one node at a time. And you want to try to not be disruptive to workloads that can't tolerate the disruption from the underlying infrastructure modifications, right? There's no notion of that being multi-cluster aware, and like there's no link between the API machinery across multiple clusters. So there's no real way to communicate an ongoing infrastructure disruption that potentially spans multiple clusters within the same region or even within the same zone, right? So typically what I've seen people do for this is you use the PDB to ensure that you aren't disrupted within a particular cluster. And then for whatever higher level mechanism you're using to orchestrate infrastructure across multiple clusters, you have some other mechanism to manage disruption, like for rolling cluster upgrades or for tolerating regional outages, right? So like PDB is not the mechanism that I've seen people use. It's not the mechanism that I've used either.
I see. Would it be like, say if we have a multi-cluster controller, which is aware of multiple clusters that are happening, and it can actually interact with PDBs, can we actually say that for this particular workload, I do not want the existing PDB controller, which is in my cluster, to take care of the disruptions, but I would like to delegate it to another higher level controller, which is multi-cluster aware? Can we have some mechanism or mechanics in place which tell that I do not want PDB controller to manage the disruptions for this particular workload? If we say in the PDB spec something which actually says, I do not want to be managed by the default PDB controller, but rather I would like to have my own. Sorry.
I don't think there's a mechanism by which the eviction controller is able to call out to a third-party mechanism in order to assess the decision of an eviction, right? Because like the eviction controller is ultimately like if you're using evict in conjunction with PDB the way you would do it. One thing that I've seen people be successful with is the creation and removal of pod disruption budgets across clusters by a higher level mechanism during infrastructure orchestration. So that would be like, you want to maintain a certain availability across all of your clusters, across all regions or across all zones, and then you lose some portion of your capacity, and all of a sudden you become less tolerant to the intended disruption. And like, let's say conservatively now you don't want to lose anything. So pod disruption budgets aren't really mutable in a very good way, but what you can do is create a new disruption budget that targets it, like a more conservative disruption budget, and then just delete the older one. And that would raise it. And then after the disruption, assuming it's not extremely long running, has passed, and you recovered the capacity and your application is now there again, you can go ahead and, you know, be less conservative with the disruption budget in the cluster. And that's the primary mechanism that I've seen it used. And granted that the orchestration to do that is complicated. I'm not saying that's trivial, but it's the way I've seen it done. Be super open to trying to do something easier. It's just, again, it's not like there's no notion of multi-cluster API machinery inside of Core, right? Like I don't have a mechanism for the API machinery to hook out. If the eviction controller, which I'm not actually sure if SIG Apps owns, like if you wanted to try to do something where we modified the eviction controller to be able to call out to a third-party mechanism via some object, I wouldn't do it with PDB. I would have it, or maybe with PDB, but have some type of mechanism that triggers the eviction controller to call out to another piece of machinery that helps in the eviction decision. That might be something, but I'm not even sure that SIG Apps actually, do we own the eviction controller? We own PDB.
I think
I don't think so. Maybe we did touch on it, but I would probably still, given that this is touching the API surface, because that lives in the API server, I would probably, even if we would be involved, I would still reach out to SIG API machinery and ask them for the feedback, because this will affect the API throughput in the long run, because you will be basically an eviction will be extended with, I don't know, some kind of a third-party call. I'm not saying that we're not doing this, because scheduler has that capability that it will reach out to for a decision to external plugins. So I'm not saying that it can't be done, but I'm just saying that we should sync with API machinery.
Yeah, it definitely would affect conformance of the entire project, right? Like,
yeah.
With regards to what Ken was explaining, I'm not sure if KubeVirt wasn't doing something around manually managing PDBs because they were overusing PDBs for managing their machines. But I don't remember the specifics, so probably would be worth
to be clear, who is that, Maciej? Kubevert?
Kubevert.
I see.
Yeah, I remember when we were talking about the PDBs default healthy. They were the ones that were talking and having some ideas around how this could potentially work, because they were also reusing, or like I said, overusing PDB for non-managing pods, but actually managing or ensuring that a particular number. But yeah, I would probably agree with what Ken was explaining with regards to having a third-party tool to manage the PDB slide, especially that you already, I assume, since you're talking about multi-clusters solutions, so you probably already have some kind of a controller written that is responsible for creating those workloads in all the clusters accordingly to whatever rules that you codified, I guess.
Yeah, to be clear, what we are thinking of doing is what Ken was suggesting, where we wanted to modify the PDBs for the individual clusters, like have a higher level controller, which is multi-cluster aware. And I mean, not modifying the PDBs, but creating those PDBs that would allow the disruption or not allow the disruption to happen. But we are wondering if the second possibility that Ken has mentioned, which is like have the eviction logic be hooked up to another external third-party controller or some other entity, which can actually make that decision for us.
I mean, it's possible. My advice, like trying to put myself in your shoes, the reason it depends on what your time horizon is, really, right? Like if you want to modify the eviction controller and get it to a beta level where it's available on most cloud providers or most distributions that are enabled, and that's going to take a while, right? So if this is a problem that you have like right now, that might be a longer way to go about it, but it is feasible. The other thing I would say is that are you like, it's a question, are you dealing primarily, like, is this a problem you have with stateful workloads primarily, or are you doing this with stateless serving workloads?
Stateful, for the most part, they are stateful workloads.
So the other thing that I've done in the past is if I have, are they heterogeneous, or is it like one particular application that is kind of core to your organization that you're worried about?
There are a couple of applications that are core to the organization that we are worried about.
So it's typically homogeneous, like say Cassandra.
Okay.
Yeah.
So what I've done in the past there, and I've seen other people do that is successful, is so for the stateful applications, you can write a custom orchestrator using a CRD that manages the cluster itself. So get outside of a stateful set world and orchestrate it directly. That way you're able to manage disruption in whatever way you want. And it's easy to it's easier or lower, there's lower barrier to entry to get a working POC out, right? For stateless serving workloads, generally, like I would not even use, like managing capacity across multiple clusters is usually a function of managing traffic ingress. Like that would be the way I would handle it. So just, like whatever you're using for load balancing across the original clusters, if you have identical instances of the application, when one part of the capacity dies, more traffic should get pushed through the additional capacity, and then use horizontal pod auto scaling there in order just to scale up to handle the need, right? So the disruption budget isn't as important there. Well, there are other ways, mechanisms that Kubernetes has to get around it. Using like writing operators or custom controllers for the workload that are capable of handling the intricacies. Because with stateful applications, a lot of times the disruption budget isn't, like it's sufficient only for availability, but the intricacies of the storage topology aren't captured by the disruption budget anyway. So like with Cassandra, for instance, a lot of times you can say, don't take down more than X of these. but it doesn't necessarily provide availability for any particular partition of your key families, right? And same with Kafka, right? Like you can say, don't take down more than X of these. But if you're looking to have like a stronger semantic around like, you know, this is how my partitions are replicated across the topology, and I need to make sure that these two don't go down, right? Like there are other kind of gotchas there. So you may want to consider that approach would be my advice as well. Like doing something custom that's specific to the needs of the application. I've seen that kind of provide a great user experience for consumers of my infrastructure.
Got it. Yeah, so I think we have some customizations in place. By that, what I mean is we have our own CID and there is a controller. But at a high level, we have been using PDBs as the disruption building blocks through which we can say, I would like to get this workload scaled down to these many pods or scaled up to more than these number of pods. But at this point of time, what we are wondering is, can we make it community compatible, where we can say that, hey, this is something that is Kubernetes is providing out of the box, or there is an extension mechanism in Kubernetes that we can go ahead and use instead of having something that we have to maintain on our own.
Yeah, no one's saying you can't walk down that path or that it would be generally unsupported. It just might be hard as well, because like Magic said, it does definitely affect the core API and its view on API. And then on top of that, it would, if you modify the behavior of the eviction controller, there's like conformance implications as well. So it's just a larger conversation, but it's something that can be done. It's just like so typically like if I've written up, like if I deploy an operator that's managing Cassandra or Kafka, or other staple workloads in the Apache ecosystem, I do deploy like PDB. I'm not saying PDBs aren't part of that solution. It's just it provides an entry point inside of the in-cluster controller that operates for that specific workload, where I can already modify those PDBs in an intelligent way as necessary, right? So that's where I've captured the logic in the past and where I've seen other people do that kind of successfully.
And you would put those railguards in or guardrails in the operator for the workload controller instead of having something.
Yeah, that's what I've done in the past, right? Because the controller is aware of the specific considerations for the workload, and it also like from a perspective, like if I'm using this because I have teams that are turning up Cassandra rings on a regular basis, right? Like a lot of times they don't want to be concerned with configuring the PDB and the API machinery. They want some API where it's like, you know, Cassandra ring or Cassandra cluster, and they put that in the YAML, and then the controller looks at that and decides what it needs to do in terms of creating PDBs, creating services, rolling out pods, whether they're using staple set or using something else under the hood, in order to make sure that works, setting the naming conventions for the Cassandra nodes, all of that stuff.
Got it.
Maybe taints and tolerations, and to try to keep things that might not be good tenants to run beside Cassandra, right? Because like you get a lot of things that hit the page cache at the same time and create memory pressure. Cassandra's not as performant as you'd like. So all of those considerations usually, and like the thing about it is like if you have a framework like that and then you open source that whole thing, that's another way to contribute it to the community in a big way that would help other people who have the same workloads that you're running. Because it sounds like a lot of what you're running are primarily internal or external versions of open source workloads that are in common use. You're not running like this custom thing that like we built, right?
Yeah, like most of them can be open source. All right, let me do one thing. Like Deep and I will go back and then we will see if we can make those changes within the operator so that those, I mean, we already have those operators being open source, but we wanted to make sure that we are not doing something that is Apple specific, or if there is a way to do it in a community way, we would like to do it that. So we'll see if those things can be put in the open source, and we will get back to you.
Sounds good. And if there's anything we can do to help, if you want to try to move an eviction controller modification forward in terms of communicating with API machinery or the other parties, reach out to me or Majek or Janet, and we can help you with that too.
Yeah, we'll do that. Thank you.
Cool. Thanks a lot, Ravi. On to the next topic, Philip and Ravi, the health policy for PDB.
So I think I should give an update on this. So I have taken the PR from Mortent and I've started working on the changes, but I think I made the mistake of making API changes and the implementation together. And I think I'll not have enough time to work on the implementation side of things. So what I'm thinking of doing is I'll make those API changes in a separate PR and then open the PR for reviews. And Philip is going to work on the implementation side of things, the actual changes that we need to make in the eviction controller. And that's the plan for this release.
But you're planning to split the work, but still get it all for 126. Okay.
Yeah, because the KEP has already merged and we are not deviating from the KEP as such. It's just the implementation that is remaining.
But you still have to update the CAP with the
release
version.
Yeah, the release versions. Yeah, we'll do that.
Yeah. I can edit this description. Not sure if Morten is reachable to ping me about updating this so that it matches the current state. And the CAP will only require updating the numbers so that it matches what we are actually doing, because I guess it is currently pinpointed to those versions as described in this issue.
Yeah, makes sense.
Cool.
We'll do that.
Awesome. Does anyone have any questions for about health policy for PDBs? Okay, hearing none. Last topic for 126 is something that Matthew Carey was working on for a little while. This basically adds a new field in a stateful set, which allows you to express what should happen with a PVC when a stateful set is either scaled down or being removed, whether the PVCs can be safely removed or they should stay. If I remember correctly, there is an updated CAP. So for those, this feature is currently in alpha. That's probably the most important bit. And Matt was pinging me about pushing this over to beta. So I think he has a PR open to address that. If you have a little bit of time and interest in stateful set, have a look at the issue and the attached PRs. I'll sync with him about updating the description as well. Okay, I think that basically concludes all the topics that we had in the agenda. Are there any other topics that folks wanted to discuss? Okay, hearing none. So with that, I'm going to give you back 22 minutes of your time. Thank you very much, all folks, for fruitful discussion as usual. And see you next time. Bye all.
Thank you.
Thank you.
Bye.